it's a meaningful equivalence between an event happening outside in the outer world and something happening inside. When you want to talk about this in a very scientific way, you're in trouble, because you will just try a rational person will just brush that off and say, well, this is just a coincidence.
Hello everybody and welcome back to Chasing Consciousness. So today on the show we have the fascinating topic of Carl Jung's concept of synchronicity. The majority of us, of course, have experienced some kind of meaningful coincidences in our lives. A few examples from mine, perhaps the right person to help with a problem got in touch out of the blue after ages at just the right time to help solve your problem. Or maybe the right book randomly ended up in front of you when you hit a block with a certain question. Or also quite common is a big disaster happens that creates complete upheaval in your life, which in retrospect, it turns out, without that disaster, you would never have arrived at a certain really important change in your life. That's also happened to me. So, of course, we've got no way of scientifically testing or falsifying either a potential coordination between these causally unconnected events, nor of testing the meaning of those coincidences to the individual. But despite that, famous psychoanalyst Carl Jung thought that meaning could be as rigorous and objective as logical deduction. And for him, that set apart synchronicities from mere statistical coincidences. So firmly planting ourselves on the subjective experience-based side of the scientific spectrum, today we're going to be exploring what Jung meant by a synchronicity and the evidence in physics that might help to explain at least the possibility of a non-local connection across space and time, or between the interpsychic world, as Stanislav Grof puts it, and the material reality. We're going to be talking to the psychologist Monica Wickman about Jung's collective unconscious concept. So listeners, please go off and find that episode if you want to familiarize yourself with that crucial idea, because I think all of these Jungian concepts are going to become more and more important as we head into the second series as well. But back to synchronicity. Who better to explain the relevant physics than the executive director of the Los Angeles C.G. Jung Institute and theoretical physicist Christoph Mouel. So having moved out of high energy quantum physics when he moved to the USA in 2007, he is passionate about the connections between physics and psychology and incredibly knowledgeable about the history of science. So I personally am feeling really lucky to have the opportunity to speak to a scientist so uniquely placed on this quite precarious bridge between the science of mind and the science of physical reality. Bolstered by his broad perspective on the history of science and philosophy, it just makes me feel a lot safer wading into this ideological minefield. So everybody, strap in tight and let's go. Dr. Christoph Mouel, welcome to Chasing Consciousness. Thank you for coming on the show. How are you?
Very well. Thanks for having me, Freddie.
It's a great, great pleasure. Christoph, I am always so curious to ask the guests about the first inklings of deep reflection, things that they remember having a really big influence on their lives, their first conscious thoughts, if you like, when they were teenagers. What were the ideas or books, perhaps, that really flung open the door of questioning for you personally?
Well, there's a few books that I could mention. I was first extremely passionate about Marvel comic books. At some point, I found one of these books when I was maybe 11. And then it really opened a whole universe for me. I started to collect these books. First, it was in French, but soon I found a bookstore where I could buy them in English. So what I did is I was 11 at that time, so I started to learn English by myself and at the end of the year, I could read novels in English. So it really opened something to me. But there was something really fascinating about superheroes for me, because if you look at Marvel comic books, what you have is a lot of scientists, a lot of people who just either had an accident due to science, like Peter Parker, or decided to work in science to change things. And so for me, it was a kind of, I could see that science was very important, something that could almost open a new mythical dimension. And I was really passionate about that.
Any particular characters? Because Doctor Strange, of course, is a very weird example, isn't he? I mean, there are so many. Was there a particular character?
Well, the main characters that I was really interested in were Peter Parker, of course, Spider-Man, Iron Man, the X-Men, all these really very special people. Doctor Strange was not one of my favorites, but I mean, it's something that I could read once in a while, but not very often. But yeah, for me, it was really the scientific side. Doctor Strange doesn't have a lot of science. It's mostly about spirituality and what kind of powers. I know that the new movies talk about the quantum realm. So they try to spin something about Doctor Strange and the quantum realm. But in my time, it was not there. So you see, actually, in the new movies, they try to talk about quantum mechanics and how it can introduce you to this new dimension of reality. And so the first introduction for me was really Marvel comic books. Then after that, around 15, I started to write poetry. So it was a very profound experience for me. It was, I started to write, and I had no clue where the words were coming from. And my poems were about big topics like death, light, darkness, nature. I've been always very contemplative and looking at things around me. Because when I was a kid, I had asthma, so I couldn't really run with my friends. I was just watching nature around me. And so I was really an introvert. And this is the kind of thing that really fascinated me. And at that time, I had no idea what I was doing. I had no idea what my poems were about. They were not great poems. They were just things coming out of me. And at some point, I saw that one of my teachers was, I was giving my poems to her, and she was a little bit worried because it was a little bit strange to have such images. And she was a little bit scared. And so she tried to see if I had issues or problems. And I didn't feel I had any problems at all. But yet one day I decided to give some of my poems to the mother of a friend who was a psychologist. And she didn't say anything about my poems. She gave me the book, Jung's book, Man and His Symbols.
Oh, wow. What a connection. What a connection from poetry to Jung's symbols. Brilliant.
And so it was, I was 16 at that time, and I really found my language at that time. I knew that what I was doing is tapping into the collective unconscious and really express deep things that were about maybe to happen. And so I kept these poems very dearly during rough times after that, because they were really a kind of light in the darkness. And at the end of this book, actually, it's not only written by Jung, it's written also by a lot of Jungian analysts, including Marie-Louise von Franz, who was Jung's most gifted student. There's a conclusion about science and the unconscious. So not only did I see that there was something called the unconscious that had an experience of but also that it was connected to science, and that there was maybe a connection between science, especially modern science, quantum mechanics, and also the unconscious, and it was really fascinating to me. So it really opened a big door for me. And I remember that in high school, I was doing the association test with my friends, trying to see what was in their mind this way. I was doing all kinds of things like that. And I was thinking about going to, I wanted to become a psychiatrist maybe. But I decided, I was always fascinated by science. So I decided to go to college and study math and physics. But still, during that time, I really trained in the science and mathematics, but the psychology was always in the background. To the point that, for example, when I got my PhD thesis, the night I defended my dissertation, I had that dream saying, well, you know, you had your PhD in physics, now it's time to have your PhD in psychology. And I was like, give me a break.
Yeah, just on the same day. You say
Yeah.
defended your PhD. What do you mean by defended in that sense? You have to present it.
Yeah, you have to present your dissertation, what you worked on during your PhD. So I was working in particle physics. So you have to present your dissertation in front of your peers. And so I had a panel with pretty good people. So one of my, the person in the room was someone who was one of the founders of string theory. And so we had it was a good event. And so, yeah, that night I was exhausted. It was really a long few years of training in physics. At the same time, I remember that my PhD supervisor was interested in Jung because I told him about Jung. So during when he would teach me physics during the day, and in the evening we would just get out of the campus and go to a cafe and speak and talk about dreams and things like that. So it was he was teaching me physics, and I was teaching him Jung and dreams.
And how interesting that there was no relief whatsoever. You were being called immediately through your dreams to go on to do psychology, which of course you did later on. How interesting. Yeah. So, Christoph, today, before we get into this, the fascinating evidence in modern physics that might do something to illuminate Jung's idea of synchronicity, let's get a really clear definition for the listeners of what Jung was meaning when he coined this term.
Well, Jung thought about this idea for almost 40 years. Actually, he mentioned the fact that the first time he had this idea, or thought about this idea, was when he had dinner with Einstein around 1909. Einstein was in Zurich at that time, and so he had dinner with their dinner together. And so Einstein was talking about the relativity of space and time, and so Jung started to think about, oh, maybe there is a kind of relativity also within the psyche. So it was, and after that he talked about synchronicity in the 1920s, and he didn't really want to write anything until Wolfgang Pauli, one of the founders of quantum mechanics, asked him to do it.
No way.
So he wanted really to make good with his promise, but at the same time he felt really inadequate about talking about all these things. And he knew that it was also a kind of danger for him because it can also be spun in a very strange way sometimes, some kind of new agey way of looking at things. And so he really wanted to stick to the facts. And so the way he defined synchronicity, I was going to say relativity, is that it's a meaningful equivalence between an event happening outside in the outer world and something happening inside. And so so maybe what we can do is give an example, the famous example of the scarab to describe different aspects of synchronicity. This is actually how the way Jung defined it. If you read his essay on synchronicity, published in 1952, he gives examples, and so it's very useful to really perceive what he was trying to say. So this example happened in his consulting room. One day, one of his patients was extremely irrational. At some point, I think Jung describes her as being stuck in a kind of intellectual alembic. And she was very Cartesian, she was very irrational, and she was not open to any argument. She knew things, she was pretty rational, and she could really argue very well. And so one day she had this dream with a scarab in the dream. And so she went to Jung and talked about this dream.
This is a type of beetle, correct? The scarab?
Yeah.
Yes.
The scarab, yeah. And then suddenly Jung was listening to the dream, heard a tapping on the window behind him. And so he got distracted and decided to go to the window. And he opened the window, and there is a kind of beetle, a kind of scarab that came in and just caught it. And he said, well, here is a scarab. And he showed it to his patient. And she was really thunderstruck. She was really shocked. And then he explained, of course, what the meaning of the scarab meant. And so you see here what I mean by equivalence. You have the image of the scarab in the dream that happens to that patient. And then another scarab outside came into the room and decided to show itself. So you have two completely disconnected events, two causal chains. One, which is, well, what's happening with the patient in our dreams, and going to see Jung and trying to maybe argue about it and be very rational. And Jung was, and the other chain is just a beetle, the other scarab in the garden coming and trying to get into that dark room, which is pretty odd. and of course, well, the person who really helped put the things together was Jung, deciding to open the window, get the scarab, and show it to the patient. So you have the two equivalent images, which are meeting, colliding, if you want, and that makes a very made a very profound impression on this patient.
And what is the meaning of the scarab, out of interest? What is the symbolism?
Yeah. So exactly, this is the main point. You need to really see what the meaning is. And so the scarab is something connected to Egyptian mythology. If you go to, if you read the Amduat, for example, you see that the sun is going down into the underground, the underworld, and it's almost in danger of being destroyed. There's all kind of dangers, all kind of things that happens to it, but still it goes under in the Amduat, and it goes under in the underworld. And the moment when the sun rises again is symbolized by the scarab. So it's really the sun coming out of the underworld, the renewal, the rebirth, if you want. And you can see that in dreams. I had dreams and synchronicities with the scarab too, which is pretty amazing, because you would think that, well, it was only maybe Jung's symbol or something that he made up, but it was not like that. You have a kind of collective dimension of the symbolism of the scarab, renewal, rebirth, which can manifest with other symbols, of course, but the scarab is one of them.
And Jung is quite later on, as you say, at the start, he didn't really like talking about things that couldn't be verified scientifically. And then he sort of opened up as more scientists took interest. But he was very keen to say, when he was talking about these kind of synchronicities, that these patients didn't know about these symbols in advance, because obviously the explanation would be, you'd read about it, or it had been in a story, or, your mother had mentioned it or something. But, he went to quite a length to be sure that the people experiencing these symbols that were clearly relevant in the analysis process had no experience of that symbol before. Is that true?
Yeah, well, sometimes people knew about this symbolism, but in other cases, you would just a patient would come to Jung and had show a dream or tell a dream, and you would just go to his library and say, "Okay, this is your dream," and show a book or an image coming from all times. So it was probably absolutely no chance for these patients to know about them. It's something that really brings a dimension of reality, objectivity, and knowing that you're not the only one with that image, but that image has resonated with a lot of people before, and it can be found in books. And so you have to be that's actually the art of the analyst, the Jungian analyst, to know about the meanings of things. Because you can just provide the meaning when people come to therapy with a dream, with certain images. And you can, if the dream is a big dream with collective symbols, you can help them with that. For example, I can give you another example of synchronicity if you want.
I think we need a few just to get our head around it, because it is such an extraordinary idea.
Yeah. It's a synchronicity told by Marie-Louise von Franz, one of Jung's best students. And so she talked in a book about a psychotic patient who one day had really a break and decided to exorcise the demon out of his wife with an axe. So, of course, the wife was really scared, and she called the police, and she called the psychiatrist too, and they came to the house. And so there was a light. There was a light in the hallway, and so when these people, the police and the psychiatrist, came in, the light just exploded. And the psychotic man said, "Well, you see, it's like." I'm the savior, you see. It's like when Christ was crucified, there was an eclipse of the sun. And so he thought that it was this guy, in his delusion, he was just making a meaning that was not really there. And so, well, everything went well eventually. The person went to the hospital. And 2 days later, Marie-Louise von Franz came to see him and his wife. And she explained what happened. She was the one who brought the real meaning and saying, well, a light bulb is not the sun. A light bulb is something made by man. It's a tool. It's something that is man-made. And so it's not the cosmic sun. And so it's more likely to be a symbol, something symbolizing ego consciousness.
Yeah.
At the same time that he had this psychotic break, well, the light exploded. His ego consciousness completely was broken into pieces. And so it was a real sobering effect on this person who realized, oh, so I'm not the savior. So it helps with during therapy sometimes to find the right meaning. It's very important.
And I can't help thinking the fact that it's an external thing, the fact that this is outside of the mind, can particularly help with the therapeutical element, because it's not in your imagination or whatever.
Yeah. Suddenly you meet reality. You meet something solid. And of course, you cannot say, well, my dream created that event. Or the scarab, for example, in Jung's case, heard about the dream and decided to visit. There's absolutely no thinkable connection It's really no causal, thinkable causal connection. I mean, there's a kind of acausal connection, something that happens. And of course, after that, when you want to talk about this in a very scientific way, you're in trouble, because you will just try well, a rational person will just brush that off and say, well, this is just a coincidence.
Well, this is a great moment to bring us forward, because that was my coming into the physics now. That was my first question, was really, am I correct in saying that, we can be clear that there is no causal connection? Because if, now we're starting to see in physics that there are some non-local phenomena which are clearly non-causal as well. So that was really my starting point of starting to think that there may be a connection with some of the discoveries in quantum mechanics and potentially also in the theory of relativity. Interesting that Einstein and Pauli were involved in Jung's bringing this idea forward. Can you list for us the research in modern physics that for you most supports, I guess the word would be, a non-local understanding of reality that could imply the existence of synchronicity as a real phenomena purely outside of the subjective meaning element that made it particularly useful, that makes it particularly useful for therapy? I'm thinking of it actually as a real phenomena. Perhaps a good place to start might be Pauli, because you said that he actually came to Jung and said, listen, you need to elaborate this. What had he noticed that he thought might be reflected in some of Jung's thinking about the mind?
Well, Pauli came to Jung because he had some problems, psychological problems. So it was the first way he met with Jung. So he was drinking a lot, he was getting into fights, and so it was not very serious at that time. So he tried to find some help to go away from this. But Pauli was very, very sharp mind. Some people say, well, you think that Einstein is the smartest person on the planet. No, you're wrong. It's Pauli. Pauli was really extremely focused on things. He could find a mistake very easily in papers. Sometimes he would just find papers so boring that you would say, he said at some point, it's not even wrong. So it's like, yeah, it's right, but who cares? So he was extremely critical. He was called, I think, the Whip of God or something like that. He had this kind of surname. And so he was so critical that, well, his mind was sometimes going too far in one direction. So he had asked for help. And so he met first with someone that was a student of Jung's, because Jung didn't want to have anything to deal with him. And then eventually Pauli started to go with Jung. And so all the dreams of Pauli can be found in Jung's book, Psychology and Alchemy. So Jung talks about a young physicist, and you see all the dreams that he had during a period of time. And this physicist is Pauli, Wolfgang Pauli. So Wolfgang Pauli had a very rich inner life. He had a lot of dreams, and he was very devoted to his dreams. He was also extremely open to parapsychology, because he had witnessed a lot of things. There's something called the Pauli effect. I don't know if you heard about it. It's a kind of effect that was surrounding Pauli. Each time, all kind of very strange happening would happen around him. Experiments would fall apart, or things like that. Physical experiments would fall apart. And so he had this reputation of, if you want an experiment to work, you need to have Pauli away from here. Otherwise, everything is going to fall apart. At some point, there's an anecdote of someone making an experiment very important in quantum mechanics. And he said, well, it didn't work, the whole thing collapsed, but thank God it's not because of your presence, because you were not there. And the experiment happened in Göttingen in Germany. And Pauli sent a letter and said, well, when did that experiment happen? And so the person who made the experiment said, well, it was that day, that time. And he said, well, I was on my way to visit Niels Bohr, and I was in a train, and I had to stop at that time in Göttingen. So it's the kind of thing that was surrounding Pauli. All kind of crazy things would just fall apart and crash when he was around. So he was very aware of the possibility of
non-local effects.
Physical effects.
And
so,
can you tell us where he'd got up to in his work at this point? Like more or less, where had quantum theory got to when he started these discussions with Jung?
It was around 1930, 1940. He studied that, yeah. The essay on synchronicity was published in 1952. So they had a very long connection together until Pauli's death. So at that time, well, most of the foundation of quantum mechanics was already there. The equations of quantum mechanics were created around 1927 with the work of Heisenberg and Schrödinger. And so the foundations were really, of quantum mechanics were already set. After that, there was a lot of work on trying to combine quantum mechanics with relativity. It was the next big task. So Pauli was working on this, on other problems. So he is a person who created the name of the neutrino, for example. The neutrino is a very elusive particle that doesn't interact with anything, well, except weakly with other particles like the electrons. And so how he was very distressed at that time when he found this particle that he created, because he thought that he had committed the biggest sin you could commit, which is to create out of thin air a new particle that just because you wanted to keep the invariance of energy in processes working. So he thought that it was a big mistake, but at the same time he did it. And so now we know that there's neutrinos everywhere. So it was probably crossed by neutrinos right now, and we're not aware of it. So he created all kind of ideas like that. There's also other things that he did, which are very impressive. I don't want to give the list of all the accomplishment of Pauli, but he's really one of the founders of quantum mechanics.
The reason I asked, Christoph, was I was thinking perhaps there was something that was troubling him that about the very nature of quantum mechanics, because I know particularly at that time, Schrödinger and Max Planck were really concerned with the implications. Some of the issues with the observer interacting with the system, and just the presence of consciousness seeming to have this inextricable effect. Do we have any record between them in their interaction with Jung that was sort of something that was troubling Pauli, and that he felt that some of Jung's ideas might shed some light on that, or is that just not the case?
Yeah, so Pauli was someone who was very sharp. He didn't want to mix completely quantum mechanics with psychology. At the same time, he felt that there was a kind of connection. Probably you would say that quantum mechanics was not complete and something else was to be found underneath. He was disagreeing with Einstein that what you would find beyond quantum mechanics was something that was restoring causality. because causality in quantum mechanics is pretty much gone. There's all kind of effects in quantum mechanics, like entanglement and other things that really show you that causality is not something tenable with modern physics. And so Einstein was pretty worried about that, and so he had a lot of conversations with Pauli. But Pauli was pretty comfortable with this kind of acausality. What Pauli was trying to do is to bridge psychology and quantum mechanics or physics. I don't know if it will be quantum mechanics, maybe something beyond quantum mechanics. But he was trying to make a bridge between the two. So his way of doing things was to try to create a neutral language. A neutral language that would allow us to talk about quantum mechanics on one side and psychology on the other. So something that was not a psychological language and not something that was quantum mechanical. So he was trying to make analogies between what you find in quantum mechanics and what you find, for example, in quantum physics. And so he was trying to make that bridge through a language. So it was his main attempt to bridge things. So it was quite interesting. If you read his analogies, they're quite fascinating.
Can you give us a couple of examples of I mean, is this something that he worked on together with Jung over the years, or this was something he brought to Jung and said, "What do you think?"
Well, he didn't really. Jung was not really didn't really know well quantum mechanics. He had a kind of way of understanding it, which was basically the understanding of someone who has no background in physics. Mm-hmm. So it was not very clear. For example, Pauli was saying, well, when you talk about physics, it looks like the dream of a physics, what I would dream in my dreams, which is about physics. It's a kind of dreamy way of doing physics. It's not very sharp and clear and conscious. So, and well, actually, Jung and Pauli had very tense connection sometimes, and Jung could tell Pauli have absolutely no mind for psychology. So it was sometimes pretty rough between the two. But at the same time, they were really discussing ideas about, for example, something non-observable. Is reality all there in space and time, or is there something that is non-visible that can really have an impact on what's happening in space and time? So it's a kind of ideas that they were discussing. They were talking about the role of numbers, because in quantum mechanics, numbers are showing everywhere, all kind of strange numbers. They were talking about this. They were talking about dreams. They were talking especially about Pauli's dreams, because he felt that there was something where he had to get out of the closet as a physicist, as someone supporting Jung. Because he felt that there was another reality that was around us, that was not purely physical. At the same time, he didn't want to talk too much about this to his physicist peers, because he thought that he was part of this academia. He was a Nobel Prize in physics, and he didn't want to go too far into what Jung was saying. At the same time, for example, the book on synchronicity that Jung published in 1952 was published with an essay by Pauli on Kepler, where he showed that, well, something happened during that time, the scientific revolution, that was pretty profound, the transition from the Aristotelian point of view to the modern point of view. And Pauli was of the idea that modern physicists should not only do physics, but they should also keep track of their dreams and all the imagination that really that they had during this creative process, because it can bring some insight about what's happening. So he felt that there should be a balance between psychology and physics, because physics is also a creative process. It's not just about discovering something out there. It's also about, it's a creative process in the mind. Why do we see what we see out there? And can this change? And so he felt that the two had to come together.
Interesting in a way that both of them were resisting the call to talk about this thing, because they were both in the academic fields. They were both very scientifically minded and evidence-based. They were both writing academic papers and books. And yet in their encounter from two such different disciplines, they sort of inspired each other, as you said, to sort of come out of the closet. Christoph, we're going to take a break in a moment because we're coming up to the hour. Listeners, obviously the collective unconscious is a very important Jungian idea connected to all of this. We're not going into too much detail about that because we have a show with Dr. Monica Wickman devoted completely to the collective unconscious. So do go back to that show if you want to hear more. But do not go away, because please come back for part 2, because Christoph is just getting started on what I think is a plethora of very, very interesting evidence in the physics that took place from Pauli and Einstein's time onwards until now, all of which I think gives us some hints to the potential. I don't want to go any further than using the word potential for some form of a non-local understanding that pushes beyond the limits of space and time, that could have, I don't want to use the word causal, but could have some connecting ability to allow a phenomenon at such a synchronicity to actually be real in some sense. So thank you very much, Christoph, for this extraordinary insight into what synchronicity is and these beautiful examples. And we'll be right back with part 2. So listeners, please do not go away. Hello, everybody, and welcome back to part 2 of this episode of Chasing Consciousness with Dr. Christoph Mouel, who is the executive director of the C.G. Jung Institute in Los Angeles. Welcome back, Christoph.
Well, thank you, Freddie.
So we had an extraordinary part 1, listeners. You must go back and have a listen. Christoph did a brilliant job of introducing what Carl Jung meant when he coined the term of synchronicity, and how he resisted quite a lot actually bringing it out, because he was very much of an academic psychiatrist publishing academic papers. He didn't want to bring forward such a potentially misunderstandable concept. And yet, of all people, it was in fact Wolfgang Pauli, Nobel Prize winning physicist, who encouraged him to do it. So an absolutely brilliant episode in part 1. And just at the end there, we really got into the detail of Pauli and Jung's exchange, which went on for many, many years and culminated, I think, with Jung finally publishing a book, which Christoph told us, in fact, Wolfgang Pauli even wrote an essay as part of that book. So I want to pick it up from there. The question that we're examining is there any research in modern physics that can really help us to understand a possible explanation for why we experience this phenomena of synchronicity, even if we can't prove it in any sort of traditional sense of the scientific word? Let's pick it up from entanglement. Christoph, I believe entanglement was discovered quite early in quantum theory, wasn't it?
Yeah, well, it was a consequence of quantum mechanics that was brought to the fore by Einstein. Einstein, Podolosky and Rosen wrote a paper in 1936, I think, to show that there is something happening in quantum mechanics because of the wave nature of reality. So that experiment that they proposed was refined after that by David Bohm, and later it was tested by physicists. And so this is what became entanglement. But basically the idea is that two particles that interact in a quantum mechanical way at some point and become almost one, when you separate them and make them go to a very big distance between the two of them, maybe light years, maybe whatever. If you do an experiment on one side of the particle, well, you will have exactly in a non-causal way the same, well, actually something opposite, but there's a correlation between the two measurements that you will make on one particle or the other, which suggests that when things interact in a quantum mechanical way at some point, well, they always give that connection whether you separate them or not. So it's connected to the wave nature of reality. You think that things are made only of particles, but there is also the wave connecting them, which is always present, whether you separate them or not. They still form the same system, if you want.
But just to be clear here, that's not a message. We're not talking about a wavelength like a radio wave communicating this change, is it? It's instantaneously happening at the same time.
Yeah, so that's actually exactly the point that Einstein, Podolosky, and Rosen were making. If you separate these particles far away, then you make far away from each other, and if you make the experiment between with the two particles, so that there's no possibility of message sent even at the speed of light, which is maximum you can reach, then there's no causal link. You cannot have a causal link because the fastest causal link you can make is using the speed of light. So if you separate the particles and they still are connected, then it means that the connection is acausal.
Well, you mentioned in part one that Einstein was quite troubled by some of the sort of seemingly non-causal effects in quantum mechanics. Presumably this troubled him even more.
Yeah, it was for him one of the things that really made him worry about quantum mechanics. It was really a spooky action at the distance. This is what he was calling this entanglement. Something that really is spooky, scary, something that may threaten the whole edifice of physics. And he thought that there was maybe something that would complete quantum mechanics. He thought that quantum mechanics was incomplete, that there was something that would explain why these two particles could connect without without transmitting information. So, for example, a kind of hidden variable, a kind of variable that would really show that they're connected anyway, even if you separate them. And so this idea of the hidden variable was tested. Actually, there was John Bell in the 70s, I think, created a kind of experiment setting to in all kind of inequalities to show if Einstein was right and if there were some hidden variables, or if quantum mechanics was right. And there was no hidden variables, but you could see this kind of connection. And so this experiment was made later by different people. And so it proved that quantum mechanics was right and the idea of hidden variable was not. So it could be determined experimentally that quantum mechanics is right and there's no hidden variable.
And what were the implications of that?
That there is a causality in the universe. There is something which is acausal, that things can be connected but not related through space. So it means that maybe space is not that fundamental.
Mm. And Einstein himself had discovered with his theory of general relativity some serious problems with the linearity of space and time itself. Perhaps you could talk a bit about that.
Yeah, well, Einstein was created his theory of relativity, and it came at a time when it was at the beginning of the 20th century. At that time, people had created all kind of new clocks that were more and more precise, so they could measure things in a better way. They could also, things were getting faster and faster. You had trains and you had the telegraphs. And so you had a whole big pressure for people to measure things in a better way with more precise clocks. And so you cannot think about relativity without thinking about clocks, because it's really about trying to synchronize things. And Einstein realized that some of the paradoxes found about the speed of light was invariant, was something that was not changing depending on the point of reference, depending on the observer. Wherever at some point people thought that if classical physics was really working well, if you change the observer, you will see some differences in the speed of things. But light was very different in that sense. It was something absolute. People realized that there was something invariant with light. It was a kind of a constant of nature. Well, this is how they explained it later. But at that time, people thought that there was maybe a kind of ether that was really the medium of light was propagating, that was really creating something special about light. And it's Einstein followed by Lorentz, Minkowski, sorry, who saw that, well, it was not that. We had to think about space and time as one. Space-time, something which is very different than Newton had said when he was saying that time was absolute and flowing uniformly without, irrespective of what was happening to the observer. So it was something that was new, completely new. And so there's all kind of paradoxes that came out of this. For example, the twin paradox. I like this paradox pretty much because I have twin sons, and they're 7 now. And so this paradox is very strange. It really shows the relativity of time. And this paradox is the following. Imagine that my twins, for example, one of my twins decides one day to go to space. And they decide, for example, to leave on the day of their birthday, the 20th birthday. And so one of the twins decide to go to space and go to visit another planet. And this technology is good enough, and you can go very fast, almost to close to the speed of light. And so, well, they say, well, let's meet in 10 years from now. And so they just have a clock in their, one of the twins is going to have a clock in the spaceship, and the other one is going to have a clock on the planet Earth. And so the person, the twin going to the other planet says, well, he's going to travel for 5 years and come back in 5 years. And so we're going to meet for the 30th birthday. And so the twin going to space does that, and 10 years later he comes back, but he realizes that, well, 20 years have happened on Earth, and so actually the twin on Earth is celebrating his 40th birthday. So it's a kind of physical effect like that, which is, and all the numbers I gave you are completely made up, of course. Mm. But this is a kind of thing that you can test in labs. You can see the effect of time being relative if you go close to the speed of light. This is something that we cannot see when we move slowly relative to the speed of light. But the faster you go and the more you see that effect becoming completely relevant and very large. So it's very, very strange to see that time can be elastic like that. It's something mind-blowing if you think about it.
Well, we're definitely going to be doing an entire show on the implications of the theory of relativity, both in this case, as you say, for motion, but also the big one, gravity, which is what everybody's desperately trying to crack. But moving on, Dr. Mouel, what else for you jumps out as an important? I like this word you've been using, acausal. I tend to use one non-local. But what else jumps out that might help us get our head around a phenomenon like synchronicity?
Well, I'm going to wear my hat of physicist. I don't think that physics is advanced enough to talk about synchronicity at all. Because science is about order. What we try to determine is how things evolve in space according to time, how things move and change, transformations in space and time. There is absolutely nothing about meaning. Meaning is not part of modern science. It's not part of classical physics. It's not part of science at all. If you mention the term meaning, you're going to be in trouble in science, and you don't want to do that. So I don't think that anything in science can really shed any light on synchronicity. Synchronicity is also, according to Jung, something which is very irregular, something which is inconstant, something that happens suddenly, and you cannot predict it. You cannot know that it's going to happen. Plus, what is meaningful for me might not be meaningful for someone else. So how do you measure objectively something like that in science? So it's really something which goes beyond science as we do it now. So what we can do only when we talk about trying to bridge science and psychology, where the dimension of meaning is so important, you have to only try to create some bridges on the pillars of all the sacrosanct beliefs that you have in physics. For example, causality. So either a place for acausality in science. And quantum mechanics shows that there is something like that. Yes, there is place for acausality, and in quantum mechanics, you have that all the time. Either a place for a creative dimension of things. That is something which is a little bit more obscure. If you go to classical physics, for example, people are mostly interested in causal chains. Try to, for example, the main idea that you have in classical physics was expressed by Pierre-Simon de Laplace at the beginning of the 19th century. He was saying, well, if you know the state of the universe, all the particles and all the forces at play, at what moment in time, then with a great intelligence, you would be able to calculate everything moving forward or backward, and nothing would be unknown to you. So this kind of belief, which is really central to classical physics, is not really good for creativity, because everything is set, if you want. Everything is determined. There's no place for creativity in there. You can see that, for example, in the last pages of Newton's Optics. He says, for example, as in mathematics, so in natural philosophy, what we need to do if we want to do good physics is to take a phenomenon and just decompose it and analyze it in small pieces so that you can really try to see what is relevant. And he spends a lot of time talking about this. And then just at the last, after this thought, he said, and synthesis is just the reverse or the opposite. So for me, it tells me that from a psychological standpoint, Newton and classical physicists are very interested in analysis. They're very interested in trying to find the cause of things and trying to determine all the pieces and elements of things. They're not so much interested in creation, synthesis. They just see it as basically the reverse of the analysis. And I don't think that in classical physics, you have a real space for any for creation, for any sense of creation, real creation. According to
do we see a resistance to the implications of acausality then? Do we find that this, I would say, expanding area of the non-locality, now we're starting to use entanglement in technology, it's going to be used in quantum computing and quantum internet. Do you think that there's an opening to acausal effects? Or do you think that in a way physics is shutting that down and that it'll never sort of be used as an opportunity to look at the world in a slightly sort of less causal way?
Yeah, well, quantum mechanics actually is marking a turn in physics because quantum mechanics is going beyond classical causality. It expresses things in acausal way because of the wave function of in quantum mechanics. And so there's really a sense that acausality is central, entanglement is central. According to some interpretations of quantum mechanics, really the core of quantum mechanics is entanglement. And this is the central piece of quantum mechanics. So it's something that people, more and more physicists are, modern physicists in quantum mechanics, are exploring more and more. They're not so much interested in, they're interested in the foundation and understanding quantum mechanics, but they're also very interested in what can we do with quantum mechanics? What kind of new technologies can we create? It's mind-blowing. We don't understand what it is. There's so many interpretations of quantum mechanics that, there's a paper by Aidan Cabello which talks about a map of madness, saying that it's really mad. It's really mad to see all the number of interpretations of quantum mechanics. We don't exactly know what quantum mechanics is about. We don't know what the quantum is about. We just know that it works very well. The formalism of quantum mechanics is the most sophisticated you can find, and it's very precise at explaining experiments. But at the same time, the central message is that we have absolutely no clue what's going on. So it's very difficult. At some point, Richard Feynman, a Nobel Prize in physics, said that that he believed that nobody could understand quantum mechanics. Nobody knows what it is. But still, all these people are brilliant, and they make all kinds of calculations, and they try to create new technologies. More and more technologies are quantum mechanical now. So you see quantum mechanics used with biology. You see quantum mechanics coming, for example, to explain some effects in photosynthesis. Also the sense of orientation of birds. You see that people are using more and more quantum mechanics in different ways, even if they don't understand what it is about. It's a way of understanding things which is really very profound. So they use it more and more. One of the examples that I like too is that some people, for example, in psychology, are using quantum mechanics to explain some biases in the way we think. It's not due to the fact that the brain is a physical quantum mechanical system. It's the fact that the quantum logic is very useful to understand the way we do things. And so there's a whole field of quantum cognition that has developed that shows that, well, it works pretty well. You use the quantum formalism to make decisions, and it works pretty well. So it really shows that quantum mechanics is maybe not about things at the microscopic level. It's a way of thinking. It's a way of thinking that shows that things are not a yes or a no, black or white, but there is maybe a tension between the two sometimes that you cannot really, which is difficult to understand because we tend to think that, well, this is true or this is false. But with quantum mechanics, everything is basically uncertain, gray. And you would think that this uncertainty and this grayness would just spoil things. It certainly spoils reason.
And causality.
But at the same time, and causality. But at the same time, it gives you some malleability. The word is something that you can shape and you can create things. And I really think that this is what is coming actually with quantum mechanics. The dimension of creativity is coming back because of this uncertainty, because of the fact that you're not trying to pin down things in space and time. We're becoming creative with quantum mechanics. And and I hope that, well, at some point, this quantum mechanics would evolve to bring maybe the dimension of meaning. What does it mean to create something?
And do you think, David, you mentioned David Bohm, do you think his idea of an implicate and an explicate order might give us some sort of physics take on the way the collective unconscious might work on some Jungian ideas? Do you think that's a useful way of separating what is measurable, what is classical, what is causal, which, is in our sort of local context works very, very well. Newton's calculations still work very, very well in the local context. Do you think this idea of an implicate order in which this probabilistic world that we're starting to see more and more is active, even at our level and even potentially at the cosmological level, not just at a subatomic level? Do you think that an idea that has that sort of humility of the implicate order, that it is implicate and therefore we will never be able to measure and define and take it into a classical scientific kind of understanding? Do you think that can help here?
Well, I'm not a fan of David Bohm, I need to say. My PhD supervisor is still a friend of mine. He works on David Bohm's work. So, I think David Bohm had something really profound to contribute to physics and also to psychology. One of the things that I really respect in what he was doing was trying to bridge the two, psychology and physics. Not a lot of people do that. He thought, for example, that we should change our way to, we should change language. He was trying to create a language called the Rio mode, where everything, to move away from just our ordinary way of talking about things with this ball is moving in that direction, which is really based on nouns. You wanted to have something which was verb-based. That you can find actually in the Hopi language and other languages. He wanted to change everything into a process. And this is what he did with this implicate order and explicate order. So everything is in flow. There's a kind of flow of things. Everything is in process. And so I think this kind of idea is profound. It's one of the the major people who talked in this way about the wave nature of reality. He was really thinking that this wave was really there, and that it was connecting things acausally. So,
is that what he meant by the implicate order?
Yeah, he was. I'm not an expert in that field, but he was thinking that there was a kind of order that was just emerging sometimes and creating what we see. And probably it was something that was also manifesting in the psyche. For me, the respect that I have was with all these people who try to go beyond the status quo and try to bring new ideas. And I think the implicate order is something that that is very, very nice to see. Jung had an idea like that too at some point in the 1950s. He talked about the fact that maybe the psyche, maybe the brain is a transformer station that create the infinite intensity of things that corresponds to basically the psyche into extension and new frequencies. So he thought that, of course, that the universe had a kind of, that the psyche was not limited to the brain. The brain was just a transformation of things. So you can see that as a kind of idea going the direction of the implicate order.
Mm. And there are any other ideas, any other particularly powerful ideas coming out of physics that can penetrate this very causal kind of limitations that we have in experimental physics? Anything else that's worth mentioning before we move on?
Everything that brings about the wave nature of reality is going in that direction, I think.
And what do you mean when you say that, Christoph? When you talk about the wave nature of reality, are you speaking about the quantum field? Are you speaking about that in terms of the wave nature of reality? What are you referring to particularly?
Well, in quantum mechanics, classical quantum mechanics, the main thing is the wave of the system, which describes the system, which really evolves according to Schrödinger's equation. Mm. So it's really that wave that is making all the trouble. If everything was made of particles, everything would be fine. But the wave is bringing all the uncertainty and all the connections like entanglement to things being separate are still connected because there is a wave underlying that. And so that's what I mean by the wave nature of reality.
Thank you. I just wanted to clarify because you've mentioned it several times. I just wanted to be sure the listeners understood what you were referring to.
Mm-hmm. And so everything that shows that things are not set, that things are not clearly located in space and time, everything that really shows these, which are connected to the wave nature of reality, everything in that direction is a step that brings us, into complete acausal territory, if you want. Mm-hmm. And so it's good to talk about it. This is a kind of thing that you want to, you would rather, for example, remove it in a way or the other. For example, there's an interpretation of quantum mechanics called the many words interpretation, which says that when you make a measurement, well, you don't see the wave, you just see one result. You see that particle being there. It's not anywhere else. So where is the wave? And so the answer to with this interpretation is that, well, when we make the measurement, the universe is splitting in many, possibly an infinite number of ways. And so I will find my particle here. But so another me in another universe is going to find the particle there, and another person is going to see the particle there. So, and all these other me, this infinite number of me's, if you want, are gonna live their own way after that, and there's no way we can connect. So it's a lot of people in quantum mechanics before think that it's the way to see quantum mechanics. That's the main interpretation. I don't like this so much. I don't like the thought that there might be many me's everywhere running around, and each time I do something or see something, there's even more me's manifesting. That kind of thinking, I think, is very classical. It says that whatever can happen will happen. And this is very classical in a sense.
In one world or another, it will happen.
Yeah, it's going to happen in another dimension.
Yeah.
And so it's a kind of basically getting rid of the wave nature of reality. There is an uncertainty in things. That uncertainty is good. It means that the world is not set, the universe is not set, nature is not set, and it's interacting with us. There's a kind of reciprocity. Our goal is not just to take things from nature and matter and try to get a result. It's to interact with it and create something with it. And this is, for me, what the message of quantum mechanics is.
I think that I have to say, Christoph, I do agree there. And, we'll be speaking to several physicists on this show who wouldn't agree with that and who prefer not to give a special place to consciousness in that system, which I completely understand why we want to avoid that, because it does open up a whole can of worms. But it does seem, looking at the data, that unfortunately the interaction of consciousness with those systems is just very, very clearly present in the data. So some of these, I do love the many worlds interpretation, just because it is so extraordinary. It's such a bonkers idea that there would actually be these real infinite number of worlds and me's out there, rather than just looking at it as a probability that some people say is the collapse of the wave function into whatever reality actually does physically happen. I want to move on, Christoph, and I want to start thinking about the idea of altered states of consciousness, because I think part of the problem here is the fact that we're so attached to our classical perception. And we love the fact that we have this sort of shared reality. And I think that some of the most interesting data, not only about the world and reality, but also about the psyche and the collective unconsciousness, is coming out of data about peak experiences. Psychiatrist Stanislav Grof, the founder of transpersonal psychology and holotropic breathing, he speaks about this play between the physical world and the psyche. And I think it's got huge implications for the nature of reality. And he says that when we're engaging with these non-ordinary states of consciousness, like psychedelic therapy or engaging with our dreams or altered states through holotropic breathing, he says that these meaningful coincidences, these synchronicities, they increase in frequency. Could it be, is there any evidence in your experience in physics and psychology even, that support this idea that an altered state of consciousness seems to potentially exacerbate this connection between what Grof calls the interpsychic world and the material world? Do we see any of that in physics through study of altered states?
Well, I don't think that physics can address any question about synchronicity once again.
You mentioned that earlier, and I wanted to say earlier, Christoph, I completely agree. And in the introduction, I was very, very honest about the fact that we can't get there using physics kind of language. Sorry, I should have said psychology there.
Yeah. Well, some studies have been made in psychology that shows that synchronicity is very frequent in the therapy room. So it's something that is part of therapy. It's really connected to meaning. Meaning is something central to psychology. So it's that's not surprising that something like that would happen in psychology. Now about altered state of consciousness, I think I know that listening to your dreams and trying to do, for example, active imagination, it's a kind of method created by Jung to consciously getting to in touch with the collective unconscious. So, for example, all the red book that you wrote and that was published a few years ago, all the black books that just came out a few months ago, are active imagination. So this kind of method to get in touch with the collective unconscious is, of course, going to come and maybe show up sometimes outside in reality, and so synchronicity might increase. So it depends on how you do, how you approach these methods. If there is a kind of necessary ethical dimension, which is to follow what meaning is pushing you to do, then I think they can increase. If it's just about getting to trying to mine the collective unconscious and use it, I don't think it's going to work very well. I think that there's something about the collective unconscious which is really sacred, which really involves a sense of respect. It's a partner. It's like nature, if you want, except that we don't read that very much. But in quantum mechanics, you have a kind of vis-a-vis. You have something to interact with. You have a kind of reciprocity in quantum mechanics. And you have to do the same thing with the collective unconscious. You cannot just go there and say, "Oh, I'm going to use this and do that." There needs to be a kind of ethical dimension to what you're doing. So, if any method to get to an altered state of consciousness goes to that point, I think it might increase the frequency of synchronicities. Yes.
And do you agree with Jung in the sense that he considered meaning, even if not in the scientific sense, but in a psychological sense and in the context of therapy, to be as rigorous and objective as logical deduction? Do you subscribe to that, or do you think it's just too problematic scientifically to see it as an objective sort of faculty?
Well, the thing is, meaning is very vague. It's not
subjective.
There can be a kind of objective meaning to things, I believe, but it's vague. It's not something that you can address in a very objective, consensual way. So people will see different meanings to things. But at the same time, you can see the effect of meaning. If you follow meaning, you can see the effect on your life. So it's something which is very important. It helps you create your own life. It helps you make sense of it. It helps you suddenly give you something to hang on when suddenly you're suffering. A lot of people, for example, suffer, and if you give them meaning, they will just go through all kind of very tough things. So meaning is very important. It's something that really helps you live. But in physics, you don't really have the dimension of meaning. People just look at, okay, what happened before and what's going to happen now. So you just try to predict things. So there's not really that dimension of meaning.
Two difficult worlds to bridge. There is no doubt about it. What about Jung's position on consciousness, Christoph? did it evolve? Did he even speak about what he believed the answer to the problem of consciousness was? Did he ever make any statements? Did it change towards the end of his career?
Well, he didn't have a firm position on consciousness. I don't think so. He felt that consciousness was something meaningful. So immediately here was something very vague. He felt that the birth of consciousness was something really almost the universe was created when consciousness was created. There is something really profound about consciousness. We wouldn't be able to see anything without it. So when people try to explain consciousness with a kind of outside perspective, it's always troubling to me to see, but what is outside consciousness? How can you go around it and look at it in an objective way? I don't think it can work. I think, for example, you cannot talk about consciousness in a classical way. It's not something moving forward. It's not a ball. It's not a rolling ball, something like that. For Jung, there was a kind of he was using quantum mechanics to describe a kind of complementarity between consciousness and the unconscious. There's a kind of conscious and conscious duality in the same way that you have wave-particle duality in quantum mechanics. Something can be conscious in one way, but it might be extremely unconscious in other ways. So there's always this kind of really very complex way of looking at consciousness. You cannot explain consciousness without the unconscious. And at the same time, when we talk about the unconscious, we always say that it's what's not conscious, but it's not quite symmetrical. And so you should really give some kind of reality to this thing which is not conscious, that actually gives rise to consciousness. So there's he was always thinking that there was you couldn't explain consciousness without the unconscious. This is where things come from. And the unconscious for him was not probably connected to the brain. I know that in neuroscience, a lot of researchers think that it's a kind of emergent process in the brain. Suddenly, well, during the evolution, something like consciousness evolved, and we became who we are. Jung was very keenly aware that the brain is very important, and he was really saying that's, well, actually, I mentioned the fact that he thought that the brain was a kind of transformer station. I mean, for him, the brain was shaping consciousness. But did consciousness, was it created by the brain? I don't think so. And once again, we come to the problem of creativity. What is creating things exactly? Do we think that, for example, classical physics or even complexity theory can explain all the everything about consciousness and the origin of consciousness? A lot of people think this is a way, but for me, I would rather go in the direction of a kind of animate universe, something where there's a kind of proto-consciousness or some kind of awareness or something in the world that does exist and that becomes refocused in us.
So you think that if Jung was alive today, he'd probably be some form of panpsychist? So. Right.
Yeah.
Interesting. Christoph, you mentioned to me off air that you believe we're in the next transition of sort of the next scientific revolution has begun. this word paradigm is thrown around a lot at the moment, new paradigm this, paradigm that. But, it is probably the right word here if we're not going to use scientific revolution. What have you noticed in the scientific community zeitgeist that gives you this idea that we're moving into a different scientific paradigm?
Well, I think that in a sense, we're still in the same paradigm, which is a scientific revolution. But this revolution is incomplete. I think classical physics gave us rationality, reason, all kind of tools that are pretty amazing. But at the same time, it's extremely reductionist. It's all about analysis. And I think that we turned the corner with quantum mechanics and maybe relativity. Suddenly things became more about this, wave nature of reality and what can we do? What can we create? It's no longer about analysis, it's about synthesis. Our whole system of science has been breaking apart in different branches. And I hope that something like the quantum hypothesis and maybe the idea of the unconscious is going to bring things back together. And one of my hope, and this is pure speculation, is that we're going to recreate a universe, cosmos, that we lost when the Aristotelian philosophy was shattered. We were in part of a cosmos where man had a meaning. There was meaning for man to be there. Man was really at the center of the universe. And I think that quantum mechanics can help us in that direction. Pauli was thinking in this way. He thought that with quantum mechanics, with microphysics, we had come back to this original sense that we were creative in our own world. We were becoming, because when we were looking at things, we were shaping things as well. And so he thought that there was this sense of wonderment in the universe, that we could really recreate things. And so for me, I see, for example, that quantum mechanics is beginning to spread everywhere. It's spreading in psychology, not just the physical science of quantum mechanics, but the formalism, the way of thinking, the logic of quantum mechanics is spreading everywhere. In psychology, we talk about the connection of life and quantum mechanics. Probably, most likely, that's my opinion, people wouldn't be alive if there was no quantum mechanics. For example, we know that there might be some quantum mechanical effects in the act of breathing. When we breathe, there's a good chance that we would die if you just listen to classical physics. But some quantum effects are here to basically make us alive. So the whole process of life is rooted in quantum mechanics, most likely. So classical physics is not a good solution if you want to be alive. You need to think in a very different way. And also, I think that it's going to change a lot of things. People in physics are not wondering, oh, we have to understand the rationality of quantum mechanics before we can do anything. They just open the door and say, what can we do with it? What can we do with it? And this is really the sign of a revolution for me. Instead of thinking too much about the past, well, you're trying to do new things, and let's see what happens.
You mentioned the word, reductionist before. That just the scientific method in itself and the necessity for experimental data and measurement, it does, it has led to the complete denial of the existence of what is beyond the material, if there is anything beyond the material. And I really like this idea that it's not a new paradigm, it's a paradigm that needs to be completed, and that quantum mechanics is a probabilistic understanding of reality actually opens the door for that last missing bit in the scientific revolution. What a beautiful idea. But I'm interested in this idea of the resistance from the causal scientists, people trying to hang on to a causal classical understanding of the world, despite all of this progress in the last 120 years. Who was it who cynically paraphrased the Planck principle, saying that science progresses one funeral at a time? I think it was Thomas Kuhn. If we look at the history of science, are such paradigm changes peaceful and gradual, based on an updating of facts or the emergence of new technology, for example? Or do we tend to just have a phoenix effect where the old ideas are just going to die hard and stubborn, and the new generation will bring them forward intuitively? What's your opinion? Is it going to be a smooth transition, this one, or are we just going to see the old hardcores dying?
Well, I hope it's not. I hope nobody is going to die. But at the same time,
we're all going to die, Christoph.
These are all hard to die. I mean, people can give their life for their beliefs. You can have wars because of beliefs. I mean, if you just look at, for example, what happened during the scientific revolution, I mentioned the fact that Copernicus suggested that maybe the sun is at the center of the universe, not the earth. And people said, yeah, okay, no big deal. It was in, I think, 1452 and 1542, sorry. And then 50 years later, Galileo came and he was in house arrest because of his ideas.
And Bruno was actually killed, wasn't he, by the church?
Yeah, he was killed, burnt at stake, because he was saying that there were many universes, well, many worlds, and also an infinite universe. Someone like it was a golden age of witch hunt. Kepler had to go to the trial of his mother, who was well, people thought that she was a witch, and so she was saved, I think. But it was really there was a witch hunt at that time, and so the witch hunt killed maybe 100,000 people, not just women. And so it was also a time of war. I mean, if you look at, for example, Descartes, we didn't talk about Descartes, but
I know you love Descartes in particular.
Yeah, you went to the crowning of a prince in Germany. Well, what is Germany now? And so after that, and this is where he had this big vision of a kind of universal mathematics. He had a kind of big dreams at the beginning of his career, and it really pushed him to do what he did, actually. But at the same time that he had this vision, well, it was shortly after, it was the beginning of the 30-year war in Europe, with about 7 million casualties in 30 years. It was a massive bloodshed. And so at the end of this war, the Catholic Church was completely ruined and partially destroyed. And so this is after that time that people like Newton could express their ideas. So the whole movement of things, not just science, is sometimes very, very bloody. I mean,
and have we matured? Have we matured since then as a society? I mean, I was thinking about the Phoenix effect, this idea that a great power, a great way of thinking, a great empire needs to crumble completely before a new paradigm can emerge in its place. This idea, do you think it's going to be like that forever, or do you think as we mature, we may learn how to make peaceful, evidence-based transitions from one way of thinking to another? I mean, that's my main question here.
Well, maybe. My point about quantum mechanics, for example, is that it proposes a different way of thinking. Things don't have to be either black or white. You don't have to fight for things and say that one is right and the other one is wrong. Two realities can coexist at the same time and create something very productive. I don't think that we need to fight for everything. You can disagree with someone, but at the same time, you can find maybe a way to live with that person. Even in quantum mechanics, you have some paradoxes about that. You can disagree about what you observe in reality, because reality is not set. It's not there. It's not determined. But two people who see the same thing may disagree on what they see, and that's fine. It's a very different way of looking at things. And if people realize that it's okay to be like that, well, maybe it can change things in the world. I don't know. But so far, I don't think that it's working very well. It's either black or white. You're right or you're wrong. There's no in between. This is once again what I was saying about the wave nature of reality, which is keeping things together. This is where creativity comes from, when two different people come together and create something new. This is really that sense of creativity which has disappeared with the age of reason. And I hope that this reason can change a little bit and opens a little bit more.
Christoph, I think that is a beautiful place to end today's deep and wonderful conversation. Christoph, thank you so much for sharing your extraordinary range of knowledge in the history of science and this difficult marriage, this controversial and problematic marriage between the subjectivity of the mind in psychology and the very sort of nuts and bolts approach in physics. I do believe, and I strongly, and I'm so grateful for your insights, that this acausality, as you've been calling it today, and this wave-like nature of matter offers us a very big clue and an open door to making this passage into into completing, as you said, what Einstein noticed was incomplete, and let's leave it on that positive note, that if we can continue to bring this sort of information to the public and both Jung's ideas and this understanding of modern physics, I think that we may well see a day where that kind of ability to coexist, that various possibilities can coexist without too much friction, can come into place. So, Christoph, thank you so much for your time.
Thank you. Thank you so much for having me.